Good morning, Lauren. Do you notice that it's quiet today? Quieter than normal. My husband is home to help with the boys today. So at least I get to teach like my first couple of hours in quiet, not third period. Good morning, Brennan. Okay, I'm going to go ahead and get going because I want to make sure we get through. We need to get through. I'm going to get you to your asynchronous time as quickly as possible so that way you get the full benefit of having all that time there to work. Good morning, Andrea. So welcome to class, everybody. And we're going to be talking, we're going to kind of shift a little bit. The last few days we've been working on rationals, okay, meaning fractions. So we're now going to combine that with radicals. Doesn't that sound like a really radical lesson? Morning, Natalie. It's super cool, right? So we're going to put rationals and radicals together. They go really well together because eventually when we get to solving radicals, they also have extraneous solutions. So the two things kind of fit very well together in our world. And then after we're done with, like, we've got, I think, like 3 or 4 sections, maybe 7-5. We're going to end up doing 7-5 and part of 7-6 today. Skimming here. So we'll be done with that one on Monday, and then 7-7 is solving. And then I think that might be it. We're really close. We'll be starting to review. So we're going to look at a test next week, and then we're going to have to, I'm going to have to get my acts together and get you guys a new notebook, right? So that we get the stuff for second semester, the rest of the stuff for second semester, at least a chunk of it, Okay, so we are in 7-5 is where we should be. So right there. Okay, so yeah, be ready. That just know that probably I'm going to guess I'm going to put it like it might be Thursday. I might put it off till the next Monday for the test because I think we're going to need the time to review. Okay, because I don't think we won't be Wednesday. 20 minutes on Wednesday isn't enough review time. I don't think. I think that's good to play a review game maybe, but not a whole review. So, all right. So maybe the week after Monday-ish would probably be the next test. So a week from Monday. All right, so radical expressions and exponents. How do you convert from a radical to a rational exponent and vice versa? And then you're going to take this one more, good morning, Juliana, one more level, okay? So you're in 7-6. So I can convert from a radical to a rational exponent or from a rational exponent to a radical. It's not a very hard lesson on this piece of it. And I believe I only took the homework from this piece of the lesson, but I'm going to have you watch on video the first part of 7-6 today as well. Okay, so make sure you get that watched before you come back to class on Monday. Okay. All right, so we are going to go through the explore. All right, because there's some good stuff in here that we need to talk about. So first of all, you have seen square roots before. I know you have, and I'm sorry that this is like super blurry. It's not quite as blurry on my original, but then when you project it, oh good, now it's sideways. That's even better. Why did it go sideways? I've never had that happen before. Go back to normal. Thank you. All right, here we go. So you have seen roots before, okay? I know you've seen them before, all right? I know you've seen how to simplify a square root. I know you've seen how to rationalize the denominator. That has been part of 7th, 8th, Algebra 1, okay? I know because my own kid is seeing that stuff right now. So you can't hide from the fact that we've never seen, you've seen that before, I know. So we're going to talk about nth root. So we're going to take this to kind of the algebra 2 level and not just have a square there. We're going to possibly have a cube or higher in there. Okay. So I'm going to read this to you because I know it's kind of fuzzy. So remember that a number A is an nth root of a number B, and this says if A sub n equals B. As you know, a square root is indicated by a radical. a cubed root is indicated by a radical with a little thing in the index. So really a square root, it's implied that there's a square in the index, and be really super careful when you're writing these things. Make sure it goes in, and notice I overemphasize that kind of B part because it's very hard to tell when we get going. If I write it like that, is that an x cubed or is it an x cubed root of something? So you really want to make sure when you're writing this stuff out that you're getting the index inside the root symbol. And I know that was a lot of time to spend talking about notation, but it's important. Okay, so in general, the nth root of a real number is indicated by the nth root of a, where n is the index, okay, of the radical, and a is the radicand. I hardly ever use those terminologies when we're doing the problem, but that's what they're supposed to be. Note that when a number has more than one root, the radical sign indicates only the principal or the positive square root. We typically, unless we're solving an equation, we typically only work with the principal or the positive square root, okay? A rational exponent. Okay, so that basically, remember the word rational just means a fraction. So we're going to have fractional exponents. Doesn't that sound like fun? Fractional exponents? That sounds awesome, doesn't it? Because we love fractions so much, and now we're going to put them in the exponent. All right, it's an exponent that can be expressed as m divided by n, so a fraction. Where m is an integer, n is a natural number, you can use the definition of root and properties of equality and exponents to explore how to express using roots as rational exponents. Okay, so they're going to actually kind of step us through this here. I don't always use these parts of the lesson because I don't always agree with what they do, but this one isn't terrible. I'm going to add probably a few other little notations in here. So it says, how can you express a square root using an exponent? They're going to take us through the algebra steps here. We're going to shortcut it and go and start converting just immediately. Okay, but this is basically kind of the proof behind how we get from the square root of a to what it is as a fractional exponent. Okay, so I'm starting with that. They're going to give us that we have the square root of a equals a to the m power. Okay, we are then going to square both sides, which they've kind of done for us. Okay. So what do we know? So here's an opportunity for you to answer something in the chat. What do you know about a square and a square root? So what would I get when I square the square root of a? You
would get a.
Okay, Matthew says we would get a. So do we know what, like a shortcut? Okay, good. Thank you guys. Okay, so kind of the way we would shortcut in saying that is that we would say, hey, these guys cancel. That's really not good notation, okay? But that's what's kind of going on. So we get a, and they're saying that that's the definition of the square root. So we now have a equals a to the m squared. This was an m in here. And then the power of a power property says that we are allowed to multiply the exponents. So 2m, we will review some of those properties as we go through this lesson, and they're reviewed again in the next lesson, okay? And then if there is no exponent there, we know that it is the power of 1, which would be the definition of first power. So I have a to the first equals a to the 2m. This is a 2m. All right. So one of our other rules, okay, is if the bases are the same, our exponents are equal. So that means I've got 1 equal to 2m. Because if a and a are the same thing, our exponents have to be equal. And then I'm going to solve. So in order to solve this, I'm going to divide both sides by 2, and I get that the m value is 1/2. If I substituted that 1/2 back in here to our original, that's saying that the square root of a equals a to the 1/2 power. So we're going to do one more of these, and then we're going to talk about the properties. Okay. So I'm going to give you a few seconds there to make sure you've got it all written, because we're going to do the same thing, but we're going to do it with cubes, and then we're going to summarize it. Okay. So how can you express a cube root using an exponent? That is, if the cubed root of a equals a to the m, what is the m? So they're wanting us to solve for m again. So we're going to do the cubed root of a equals a to the m. That's where we're starting. Okay. We are going to cube those sides. So I've got the cubed root of a cubed equals a to the m to the third power. And I know that's kind of fuzzy. All right. We talked about this in the first one. Last time it was squareds, now it's cubes. The cube and the cubed root should cancel, so I should get a equals, they're going to go a, they don't combine their steps at all. They're going to do that first. Then we're going to write it as a equals a to the 3m. All right. So what, help me out with this one here for this definition of the first power. What exponent is always there? So what exponent is always there if there's no exponent? Nice job. It is always a 1. Okay, so make sure, it's sometimes we get 1 when we have to be a 1 and when we have to be a 0 confused. So be really careful. It is always a 1. Good job. All right. So that means I now get to use the bases are the same exponent. So the bases are the same. I can equate the exponents, meaning I can set the exponents equal. All right, what am I now going to do to get m by itself? Can you guys tell me that in the chat? What do I have to do to get m by itself? I'm going to wait just a few minutes, another minute here. Make sure we're all getting a chance to process that. Good. I like the /3. That's a good notation for, I don't like slash, I hate slashy fractions. I don't know if you guys have noticed that. I always draw my fractions horizontal, but for the, whatchamacallit, for the divide, I'm okay with that. We know what you mean. So 1/3. So now I know that the cubed root of a equals a to the 1/3 power. All right. So let's summarize a little bit what we've done. So we're already down here on reflect. So it's asking us, examine the reasoning in steps A and B. Can you apply the same reasoning for any nth root A, or the nth root of A, where n is a natural number? Explain, and what can you conclude? Okay, so we're going to do this same process again. I'm going to do with n's. All right, so let's see if we can do this more in general. So, and I'm going to use all these lines that are here. So if I'm starting with the nth root of a, I'm not going to show quite as many steps as they did, equals a to the m. Instead of raising it, so last time, in order to get rid of the square root or the cube root, we squared it or cubed it. What exponent, if I'm going to try to get rid of the nth root, what exponent do you think I'm going to need to use to get rid of the nth root? Natalie, you're awesome. Good job. Okay, we are in fact going to have to use an n. Okay, so I'm going to do n. I'm going to raise both sides to the n, which means that we are canceling these guys, right? So I have a equals. Then we have the power to a power thing going on. I think they use too many steps, so I'm not going to use as many. So a to the m times n. I know my bases are the same. I know that you guys told me that there's an exponent of 1 on that, so I can equate my exponents. So 1 equals m times n. And we're trying to solve for m right now. Figure out what m is supposed to equal. So I'm going to divide the n to the other side. So 1 over n equals m, meaning that if I have the nth root of a, that's the same as a to the 1 over n power. So we basically just proved an algebraic property today. Okay, you should feel super important because we did 3 proofs, right? They weren't like given of the statements and the reasons, not those kind of proofs. It's an algebraic proof. So here's the shortcut. You ready for this? Because we like our shortcuts, right? In algebra 2 with trig, we don't like, that's way too much writing to deal with, isn't it? Good morning, Gavin. So when I have like the square root of x, technically this is to the first power and this is the squared. Let's do another one too at the same time. Cubed root of x to the first. So you know the trees that we have outside. I should have drawn this in green, right? Okay, the trees we have outside. okay? The roots of the trees, those are my roots, okay, are at the bottom of the tree. Roots at bottom. Okay, so this is the way I remember this. The root, whatever's in the root, goes in the bottom of the fractional exponent. So this would be written as x to the 1/2. This one would be written as x to the 1/3 because the root goes in the bottom. And if there's no exponent there, you know it's a 1, so a 1 goes in the numerator. Okay, so I'm going to give you a what if, and you're going to tell me in the chat what you think it is. What if I give you the cubed root of x squared? It would be x. What would my new exponent be? Tell me in the chat what's my new exponent. All right, good job, everybody. We're doing great. It is definitely 2/3. Okay. I will tell you, we use this thing here almost every day in calculus. Okay. You have to just know that when you see square root, it's same as x to the 1/2 power. So this is actually, it's such a tiny, tiny little thing, but it makes our life so much easier when we go to the next level that we understand that and we can convert really fast. Okay. We don't see a lot of 2/3 powers in calculus. We don't even really see 1/3, but that 1/2 power, it's all over the place. Okay. Now this lesson is going to translate this to numbers a little bit. Okay. So it's asking us, looking at what I did before. 2 and 3 to explain. Okay. So for a positive a, under what condition? Because I'm going to kind of explain the positive and the negative at the same time. We're looking, so notice this one says positive and this one says negative. So it says for a positive number a, under what condition on n will there only be one nth root, two nth roots? Explain. Okay, so let's play with that a little bit. Okay, if I have 2 cubed, I know that that's 8. So if I take the cubed root of 8, I get back to 2. Okay, if I start with -2 cubed, I get -8, right? Because it'd be -2 times -2 times -2. I would get a negative number. Okay. So when I take the cubed root of -8, I'm allowed to take the cubed root, or an odd root is allowed to have a negative under there. I would get back to, sorry, I got to get plugged in, to -2. Okay. So when I have an odd exponent, I know I'm going to get one answer. So one answer for an odd exponent, or an odd index, right? Not really an exponent, an index. All right. The even, so let's play with this with an even number. So 2 squared we know is 4. But when I take the square root of that, I really honestly could have had plus or minus. Okay. I could have even started with -2, but when I take the square root of that 4, I could still get back to plus or minus. So I can't have the negative under there. That's what we're going to talk about in, that's when we get to the i's. So to get 2 real solutions, this was 1 real solution, okay? 2 real solutions means that I have, or 2 real nth roots, it means that I have an even index. And then it's asking for a negative number a, under what condition will there be no real nth roots, 1 real nth root? Explain. So with the negative here, we kind of explained here. When it's odd, we get 1 answer either way. Okay, so that's the 1 nth root for that answer. The negative, when we have the negative underneath there, like a -4, we're going to end up with 2i, right? So it's no real when it is even out here, right? And negative in the radicand. So no real nth roots when negative in radicand with a even index. All right, let's get into kind of the more exciting part of the lesson, because it's kind of dry so far, right? I agree with the fact that it's dry so far. Let's get into actually solving some problems instead of all the theory and explanation beyond the problems, right? That's the part a lot of us enjoy. We don't always enjoy the theory part, but we have to get to it. We have to explain it. So in the Explorer, you found that the rational exponent m over n with m equal to 1 represents the nth root of, this is going to be a to the, let me see what this is over here, 1 over n equals the nth root of a for a positive values of a. This is also true for negative values of a when the index is odd. When m is not equal to 1, you can think of the numerator m as the power and the denominator n as the root. We've already kind of talked about that. The following ways of expressing exponent m divided by n are equivalent. So they're basically saying we've got some ways to express rational exponents and they're all the same. I'm not going to mess with the numbers part. I'm just going to look at the algebra representation. So it's a to the m over n is like saying the nth root of a to the m power. I could say that exact same thing by saying the nth root of a to the m. So it doesn't matter if the m is on the inside or the outside, no matter what, we're going to get the same value, okay? I can go back up. Yes, sorry, Brennan. I just saw that. I'll leave it there for a minute, okay? You're welcome, kiddo. It is. If I ever need to re-explain, you guys got to stop me, okay? You can tell me to re-explain. It's okay. All right. So let's take a look at some examples. All right. I think that there's only, so just example 1 in your turn. Yeah, just example 1 in your turn. So we're almost done, believe it or not. First part was just long. All right, so part of the key to this is making sure you understand sometimes what the bases are and renaming numbers, okay? So it says translate the radical expressions into expressions with rational exponents and vice versa. Simplify numerical expressions when possible. Assume all variables are positive. No two of these is going to be exactly alike, and you're going to have to kind of go with what we've learned the rules are in the homework. I'm assuming they'll see some that are similar when I pulled the assignment, but you might see some new things pop up. Okay, so when I see something that looks like a here, which is to the 4/3 power, and got to be careful. Look at how I wrote that. It looks like I'm multiplying it by 4/3. I really should have done this, right? I really have to be careful to make sure that exponent goes high, okay? Even if it's overemphasized high, okay? All right, I am going to rename 125. If this was 25, let me give you an example. If this was 25, I could rename it as 5 squared, okay? What's another name for 125? What do you guys think? You guys tell me what you think in the chat. Another name for 125. Something to some power. Something to some power. What do you think it is? Any ideas? Okay. I like it. I like it. I like you seeing the 5 to the 3rd. The only catch I'm going to put on now, see if anybody gets it. I still have a few more coming in. Got a lot of 5 to the 3rds. Some of us are figuring out the cool looking exponent. All right, so here's my catch. So let's talk about this. I need to get negative 125. So if I multiply 5 to the 3rd, that says 5 times 5 times 5. So 5 times 5 is 25. 25 times 5 is 125. But I wanted negative 125. Would we like to adjust our answers? There we go. Matthew got it adjusted. Abby got it adjusted. All right, we want negative 5 to the 3rd. And we need to be careful. This is a picky thing, okay? And I know we're typing into a chat and we're doing this as fast as I can. So I know what you're trying to say. Let's talk really quickly about the difference between this and this, okay? And it's more for if you ever put this into a calculator than anything else, okay? If you put this one into a calculator, it's gonna, well, they probably both would come out the same because it's a cube, but if it was a squared, it wouldn't. So what this says is it says -1 times 5 cubed, okay? This one says I'm going to do -5 times -5 times -5. Though they would both get the same answer in the end, if I had an even exponent, you wouldn't. Okay, so you have to be careful and watch the notation. So technically there's parentheses around it. Okay, so if you want to impress me next time, put parentheses. When there's only what's negative. All right, so here's the nice part about this. See how we've got a power to a power. We know we're supposed to multiply the exponents when we have a power to a power. Because I'm multiplying, don't those guys cancel? So now I have -5 to the 4th power. Does anybody know what -5 to the 4th power is? Or can do it really fast? -5 to the 4th, any ideas? Oh, there we go. We got a 625. Good job, Natalie. All right, so that's one of them. I simplified the number. I didn't ever convert it into a radical though, right? So let's try doing some that where we convert into a radical. This one is supposed to say x to the 11/8 power, okay? I don't know how simple they're gonna go. I'm looking at what my notes were from last year. So all I'm gonna do is I'm going to take that root, the root is in the bottom, right? So whatever's out in the bottom is gonna go in the root, in the index, and it's going to be x to the 11th. Did they want me to? It says simplify numerical expressions when possible. It doesn't say to simplify that. So I'm going to go on the assumption that we don't need to simplify that more, that they just want us to do the conversion. Okay. This one here, so the first one was super complicated. The rest of them aren't that bad. All right, this one here is supposed to be the cubed root. No, not the cubed root. It's supposed to be the 5th root. The 5th root of 6 to the 4th power. Okay. All right. So if I was going to convert that into an exponent, it would be 6 to the 4/5 power. I don't know. I didn't write down any further. They might want us to, I don't know if they'd want us to make it to the 4th power and then take the 5th root of it. That kind of seems silly to me. So I'm going to leave it like that. All right. This one says 4th root of x cubed. So in order to convert it, again, whatever's on the index on the inside exponent is going to be on the top. Whatever's on the outside is going to be on the bottom. So over 4. Easy peasy lemon squeezy, right? We want like 12 of those on the next test, correct? We might get 1, maybe 2, going 1 each direction, right? 1 into the root and 1 out of the root. That's pretty good for my tests, right? That'd be a lot. All right, let's go a little bit more numerical here, okay? I am going to start by, I know that one of my properties is that I am allowed to distribute this in, and that's a 3/4 power there. So when I distribute that in, okay, I'm going to at the same time kind of rewrite things. So I'm not going to distribute quite yet. Do we have another name like we were doing 2 squared is 4, okay? Do we have another name for 81? What's another name for 81? Is something to some power. Big hint, I probably want that power to be a 4, so I can cancel it with that denominator. Any ideas? What base, so what number to the 4th would be 81? Anybody got any ideas? Natalie, good job. 3 to the 4th. Okay. So we're going to take a second here and we're going to write something off in the left-hand column, okay? Because powers of 2 and powers of 3 are very important, and powers of 4, so it's not a bad idea to know some of these. So let's see, how do I want to go with this? Let's just do 2. So 2 squared is 4, 2 cubed is 8, 2 to the 4th would be 16, 2 to the 5th, 32, 2 to the 6th, 64, right? Yeah, right. Okay, so those are powers of 2. I could keep going, right? Powers of 3. So 3 squared we know is 9. 3 cubed we know is 27. 3 to the 4th is 81. That comes up a lot. That's about as high as I would probably need to know for 3s. 4s, probably not as much. I don't see it popping up here. So, but I would know those. Sometimes you get 5 to the 4th, but know that that's kind of the pattern we're looking for. Okay. So now I want to kind of do the same thing with that 16. So what to the 4th power is 16? Can you tell me that in the chat? So what am I gonna rename my 16 to in the denominator? Good job. 2 to the 4th. All right, now we're going to do our power to a power thing. And again, these are exponent rules you are supposed to know from 7th, 8th, and Algebra 1. Okay, so we've got 3 to the 4th times 3/4 is that exponent, and 2 to the 4th times 3/4. All right, so these guys cancel, because this one's numerical, I got to simplify, right? So 3 cubed over 2 cubed. 3 cubed is 27, 2 cubed is 8. So we would get 27/8, and I don't think it goes any more than that. Give you a couple seconds on that one. All right, this one is to the 5/3 power. I'm not really, there's a lot of different ways they could do this. They even said there was more than one way to write it. So I'm just going to convert it into a radical, because that's what we're supposed to be doing, really, is converting to a radical. So this one here, tell me in the chat, what number is going to go out here as the index in the radical? Can you tell me that? What number is going to go in the index of the radical? Awesome job. It's going to be a 3. Good. So it's 3, and then I'm just going to write xy to the 5th. You could distribute the 5 in there, so it could be cubed root of x to the 5th, y to the 5th. I guess they could write it like this. You're going to kind of have to go with whatever you might have to play with it a little bit. It could be either one of those. Okay. And again, I don't think they're simplifying. They didn't say to simplify ones that weren't numerical. All right, let's take a look at this one. So now I'm going to go back the other direction. I have the cubed root of 11 to the 6th power. Okay. So where is the 3 going to end up? Is it going to end up in the numerator or the denominator of my fractional exponent or my rational exponent? You guys spell and type really fast. You guys spell denominator fabulously. Good job. So 6/3. I can reduce 6/3, right? 6/3 is the same as 2, and I know 11 squared would be 121. Mathematicians have a hard time of not simplifying all the way, right? Okay, when they tell us not to simplify all the way. All right, here is the last one of this on this page. We've got the cubed root. This is a 2x over y to the 5th power. Okay. So first thing I'm going to do is I'm going to convert it into a fractional exponent, okay, because that's what we were supposed to be doing. In fact, that's probably all I'm going to end up doing with it, is converting it to a fractional exponent. So it's going to be 2x over y to the 5/3 power. All right, we are going to do just a few more. We're going to skip the reflect, so you get to cross out reflect, okay? That was apparently my curly Q cross out X. All right, we're going to go down and do your turn. And again, we could see a million of these and we would never see everything that we are supposed to have here. They get a little bit more abstract on these because they take away numbers and put in letters. So we'll just see how it goes here. So we have in this first one, it says, I'm just going to rewrite it. It's negative 32 over 243 to the 2/5 power. Okay, and I'm going to leave, we'll have to do that work there. All right, so I need another name for 2. Or sorry, for 32, not for 2, for 32. Think about it though, I probably wanted to have an exponent of 5. So what's another way I could write negative 32? Okay, watch our signs, which I need to get a negative 32 out of it. All right, nice job. And this is, again, another case for the fact that we do want to always have that good habit of putting parentheses around that. All right, what about 243? I didn't get that high with the ones we wrote out, huh? We should have written more. Let's see, because I said, oh no, we won't need it beyond the third one. What's 3 to the 5th power, maybe? Okay. So this one here, 243, is actually 3 to the 5th power. All right, I am going to distribute this in. So I have negative 2 to the 5th to the 2/5 power over 3 to the 5th to the 2/5 power. And again, I had to have that double parentheses on that first one because of the negative sign. All right, what do I get to do with all the 5s now? It's like our favorite thing in the world, right? What do we get to do with all the 5s? We do. We get to cancel them. We get to cross them out. That's right. Okay, so we are going to cancel them. So we get negative 2 squared over 3 squared. Negative 2 squared is 4. 3 squared is 9. So we end up with 4/9 on that one. Okay, let's take a look. I'm going to jump down to C before we totally blow it and forget C. C is the cubed root of 0.5 to the 9th power. Okay. So where is this 9 going to end up when I convert it to a fractional exponent? Is it going to end up in the numerator or the denominator? All right, nice job, you guys. It's going to end up in the numerator. So I end up with 9/3, which that's kind of nice, right? Now I've got 0.5 squared. Sorry, not squared, cubed. Apparently I can't divide this morning. Cubed. And 0.5 cubed, if I were to multiply that out, it would be 0.125 would be the answer on that one. All right, let's take a look at B. B is a little bit weird. I'm going to rewrite it because it's hard to read. 3y to the B over C power. So they got rid of all the numbers. Okay. I have to convert it to a radical. So which one is going to end up out in the index of the radical? What part of that is going to end up in the index of the radical? All right, nice work. It's going to be C. Good job, everybody. And then we have 3y to the B power. All right, last one. This one says the U root of ST to the V power. And remember, that's the same thing as saying the U root of ST to the V. Remember, they're equivalent statements. So if I'm going to convert this to a fractional exponent, what is my exponent going to be? So what's my new exponent? What do you guys think? And you might have my permission to use the slashy fraction, but just on the typing part. All right, nice job. It's going to be the V is going to be the numerator, and always what's in the index of the radical is going to be the denominator. Okay. So the big thing you should have gotten out of this lesson is whatever's out that root goes up in the exponent. And then the other pattern you're starting to look for is when we're simplifying these fractional exponents, you want to create something here that would cancel with the denominator. Okay. Those are the two big things. And I'm going to give you another little bit of a gift here. We're going to get rid of on elaborate, get rid of 10. You can answer the other two. Okay. All right, so what you have left to do, okay, for your asynchronous time, which remember could be done sometime between now and Monday. You want to get this done though before you come back, okay? Is we're going to go into Google Classroom right here and the classwork section. And we're going to look at, okay, so I made a boo-boo, okay, when I was doing things. So we just did the live lesson, okay? You're going to go do video lesson. All you have to do is get through explain 1. I want to say it's maybe 10 minutes of video, okay? I split it into a couple. It's pretty quick, okay? Oh, this shouldn't be homework 17. It should say 18 and 19. I'll fix it right now. So I had a typo when I put this into HMH and I couldn't get it fixed. It's supposed to be homework 18 because I realized that finally that this was 17 and I totally messed up the number. So, but HMH wouldn't let me change it. So it's officially 18, but in HMH it's going to say 17, okay? That lesson, that homework will be based on what we just did today together, okay? We'll pick up the stuff you're going to do in video with Monday's lessons homework. Okay, but I want you to do a little bit of extra video work so we don't have quite as much on Monday. Okay, are there any questions, comments, concerns? All right, let me fix this really quick here, and then you're just in case you've got one, I'm going to fix it here. So you got to work on 18 and 19. You're only going to turn in the notes that we finished today. The 7-6 notes won't come in until next week. Okay. All right, I'm going to see if I can fix this so it's not pink, because the pink is a little bit bright, driving me crazy. So I know some of us like pink. That pink is just, it's a little bit nuts for me. So I think I figured it out, but I'm going to have to mess with it a little bit. I don't want to lose our cool logo at the top, right? Our cool banner. All right, let's do, you guys are still the only ones that have them, or that has that one. Let's